Okay. All right. Few word problems. We got ball player's going to hit a home run. The path of which was modeled. The path of, is that word that right? The path of which was modeled. I guess it is. It just sounds really wordy. The path of which was. Oh, I gotta quit thinking out loud. Was modeled by this equation. Okay, here's where we're getting at. And so basically, here's what's happening. Guy standing at the plate. He's going to hit the ball. And think of this. When you plug in x is 0, it leaves 5. So I know the y-intercept's 5. It's a parabola. He's going to hit it up in there. It's going to fall. Eventually, it's going to hit the ground. When I watch the news after the game, how far will the sportscaster say the ball was hit? Well, from where he is to where it lands, that's how far you say they hit the ball. What's the maximum height of the ball? Well, that's going to be whatever this is, the y value of the vertex. And then how far above the ground did the bat make contact with the ball? Well, we're going to figure that out. Because when the ball hasn't moved after being hit, it definitely is at 5. So how far above the ground did you make contact with the ball? Oh, I didn't even say everything was in feet. Goodness gracious. Let's say it's 5 feet high. Darn. Already. I hate when I mess up. Especially when I already run the copies before I realize I messed up. So you made contact with the ball 5 feet above the ground. Or 5 units, I guess we should say. Let's say 5 units. Because I really don't know. No, that sounds silly. Let's just go ahead and say I forgot to put feet. Call it feet. I'll be honest, this is one I would not complete the square on to get the vertex because it's got all those decimals and stuff. I would still use the negative b over 2a on this one because it's going to be easier. So the opposite of b is negative 2. Twice negative 5/100ths is negative, what's that going to be? 5/1000ths. Twice it'll be 1/100th. So it'd be negative. So 2 divided by that. X is 200. Does that seem normal? That seems awfully high, far for it to be halfway. I don't know, maybe. So if this is 200, let's figure out how high it is right there. I plug a 200 in. Negative 0.005 times that 200 squared plus 2 times 200 plus 5. Okay. So 0.005 times 200 squared plus 2 times 200 plus 5. Okay. So that gets me 205. So there's the maximum height. Because that's what that vertex is. It would be at 200, 205. Now, when it hits the ground again, right there, that's when that will be how far it traveled. So I want to know when the height is 0. So I'm going to take that equation. Set it equal to 0. I don't like to lead with a negative, so I'd probably either move everything to the other side or just divide both sides by -1. And I don't know, might as well quadratic formula. We're going to be rounding this off anyway, I'm guessing. So opposite of b plus or minus the square root of b squared minus 4ac. So 0.005 times a -5. That's negative 25,000. Oops, 25,000. It's not hundreds. That looks weird. All over twice that a. Can't believe I just punched that in a calculator. Okay, so plus or minus 4 times the 0.025 plus 4 more. That's going to get me a 4.1 under there. All right, so x is either 2 plus the square root of 4.1 all over 1/100 2 minus the square root of 4.1 all over 1/100. Think of this. The square root of 4.1 is definitely bigger than 2. So if I do 2 minus a number bigger than 2, that's a negative. That's just telling you where it would have hit the x-axis over here. That's not the one that's going to tell you from the 0 feet to wherever it's going. Like, this is the one we want. So 2 plus the square root of 4.1. Divide that by 1/100. So they'd probably end up saying it was about a 403-foot home run. Okay. All right. Next one. Somebody is 75 feet up in the air, and they drop this water balloon. So it's going to fall straight down. So it's like we're not going to be describing the path of the ball, but what we can describe with the parabola is if we think of it as the time that passes after you drop it. And here's the height, where definitely that's the equation. It's just a parabola that got flipped upside down. It's a vertical stretch and moved up 75. Like, it's going to look like this, where this is going to be up at 75. Find the maximum height of the balloon. Okay, well, I don't need to do any work there. The maximum height of the balloon is that 75 feet that you're dropping it from. The time it takes to hit the ground is from the time you drop it, and then a bunch of time's going to, oh, not a bunch, probably. Some time's going to elapse until that height is 0. So we're going to figure out what makes the height 0. So t squared is 75 over 16. Now, watch on this one. I could get both of these numbers, but we're not going to go back in time. Like, I don't want to pay attention over here. This is the only reason I'm not putting plus or minus. So the time that elapses, I know there's a 4 down here. 75 is 25 times 3, so it's going to be 5 root 3. Was it in seconds? Yep. That's how much time is going to elapse. Let's see how much that is, approximately. So about 2.1, let's just say about 2. Let's just go 2.165 seconds. That's how long it's going to take for it to hit the ground.